Next, we'd like to practice our synthetic division by doing several examples. We're going to be working the examples on the left column. On the right column, just go ahead and leave that for now. We'll come back to that in just a minute. So I'm going to synthetically divide 3x squared plus 5x plus 2 over x plus 1. Notice x plus 1 is a linear polynomial with leading coefficient of 1, so this is a synthetic division case. Inside my division bar, I'm going to put the opposite of positive 1, which is negative 1, and then use all of my coefficients. Note that this is x squared, the next one's x, and the next one's number. We never had any missing terms. Once you have x squared, you need to have a column for an x and a column for a number, all the degrees lower than it. First, I'm going to drop my 3, multiply 3 times negative 1 to get negative 3, and add down. Multiply, add, multiply, add. I'm getting 2. 2 times negative 1 is negative 2, add down. A 0 tells me that I have a 0 remainder. And so my solution, or the answer for our division problem, is equal to 3x, notice it was an x squared, but I'm dropping the exponent by 1, plus 2, which is a number, and then I don't have a remainder, so I don't even actually write the remainder part. So it's just 3x plus 2, and that's the answer. Synthetic division is much more simple than long division. It takes a lot less time. Next, I have an x minus 1 as our divisor. So inside the bar, I'm going to put the opposite of negative 1, which is positive 1. And then I'm going to use my coefficients. And the coefficients here are 3 for the x squared. The next column needs to be x, and the next column needs to be number. But notice in the dividend, we don't have any x's. So I can put my 5 in the number column, but I need to leave something here in order to denote that I had no x's. And the way we do that is to put a place holding 0. If I have an x squared, you must have a column for x, and then you must have a column for a number. Similarly, if my highest degree was 4, x to the 4, then you have to have a column for x to the 4, x to the 3, x to the 2, x, and number. You have to have all of the degrees one integer lower than it. Next, I'm going to bring down the 3 and multiply and add. 3 times 1 is 3. I add down to get 3. I don't have to subtract because I've already changed the sign. 3 times 1 is 3. I add down to get 8. Well, this time I do have a remainder. So the answer to 3x squared plus 5 divided by x minus 1 is 3, drop my exponent by 1, x, plus 3, drop my exponent by 1, but this is a constant, plus my remainder, 8, is still being trying to divide it by x minus 1, the original divisor. And this is the answer to our original division problem. On the next one, my divisor is x plus 5, so inside my division box, I'm going to put the opposite of positive 5, or negative 5. Then I'm going to put the coefficients of the dividend, or the numerator. Bring down your first leading coefficient. Then I'm going to multiply and add. 1 times negative 5 is negative 5, add down. Negative 1 times negative 5 is positive 5, add down. 0 times negative 5 is 0, add down. Notice that my first exponent was a cubed, so that means I drop it by 1, I get an x squared. My next one was an x squared, I'm going to drop it by 1. Negative 5 was an x, so that would be my constant down here, and my negative 9 was my number, so this is going to be my remainder. So the answer to our division problem is 1x squared minus 1x plus 0 as a constant, so I'm not going to write that, minus 9 as my remainder over x plus 5. On our last problem, we have a divisor of x plus 2, so inside the bar, I'm going to put the opposite of positive 2, or negative 2. Notice that I don't have very many terms on the numerator, or the dividend, but I do have a high degree. I have 1 x to the 4. The next term I have is a minus 16, which is a constant. But you need to fill in zeros for all of the missing terms. If I have an x to the 4th, you need an x cubed, an x squared, an x, and a number. You have to have all of those columns filled. Well, I have no x cubed, so I put a 0. I have no x squared, so I put a 0. I have no x's, I put a 0. But I do have a constant. My constant, or number, is negative 16. Now I can bring down the 1 and multiply and add. 1 times negative 2 is negative 2, add down. Negative 2 times negative 2 is 4, add down. 4 times negative 2 is negative 8, add down. Negative 2 times negative 8 is positive 16, add down. And we have a 0 remainder. For now, it doesn't matter if you have a 0 remainder or not a 0 remainder, but in the next couple of sections that we'll be talking about, having a 0 remainder is going to be very helpful to finding the zeros of a polynomial. So usually we like to cheer whenever we get a 0 remainder, but in this section it doesn't really matter if your remainder is 0 or not 0. You're still going to get an answer. So my quotient is here at the bottom. It was x to the 4th to begin with, so when I dropped it by 1, I'm getting 1x cubed minus 2x squared plus 4x minus 8 constant plus the 0 remainder, but that's kind of silly. No one writes a 0 remainder. We don't have to mention what we don't have. So we're just going to erase that and finish up our problem. So if we have a function f of x, and let's say that that is our dividend, and that appears in the numerator, and we're going to have x minus c be our divisor. Like we mentioned earlier, it has to be a linear term with a coefficient 1, so we're trying to find our c. Let q of x be the quotient, so that's our answer, q of x, and r be the remainder, and where we put the r was the numerator divided by the divisor. And this is kind of what we've been doing. I'm just using a little bit more general terms. So if you take the polynomial in the numerator, divide it by the linear binomial with a coefficient 1, you get the quotient plus the remainder over the original divisor. But if we multiply both sides of the equation by x minus c, we're going to get an equivalent statement. So let's do that. X minus c, if I multiply it by both sides of the equation, I'm going to multiply it by every single term. Notice what happens here. The x minus c's divide out. So I'm just left with f of x is equal to q of x times x minus c. And the x minus c's here also cancel out. We get plus the remainder. Why would this be helpful? Well, if you're taking a polynomial and you're trying to factor it out, we can divide it by a divisor, and if you have a remainder, we can write it as a new statement. Now we're going to rewrite our dividend f of x for all of the previous problems that we just did. I'm not doing the synthetic division again because I've already done it. I'm going to be rewriting the numerator as a product plus a remainder. So going all the way back up to the top here, we have f of x being 3x squared plus 5x plus 2. Notice that's our numerator here. And x plus 1 is going to be the divisor. Again, that's what we did here. All I want you to do is rewrite f of x is equal to the quotient times x minus c, the divisor, plus the remainder. So who is the f of x? Well, in this case, our f of x was 3x squared plus 5x plus 2 is equal to the quotient, which is 3x plus 2, times the divisor x plus 1, plus the remainder. In this case, the remainder is 0. So because the remainder is 0, we're just going to go ahead and erase it, and we don't mention it when we don't have a 0. So this is the factorization of this polynomial. Because the remainder is 0, synthetic division not only divided by the divisor that we were trying to work with, it also factored it. Because there is no plus a remainder at her, this is the true factorization of 3x squared plus 5x plus 2. So when you have a 0 remainder, you also factor the polynomial. Next, if f of x is the numerator, 3x squared plus 5, and the divisor x minus 1, we're going to rewrite f of x as a product of the quotient times the divisor plus the remainder. In this case, we have 3x squared plus 5 is equal to the quotient. Notice the quotient is just the whole terms times the divisor x minus 1 plus the remainder 8. You don't include 8 when you're writing out your quotient. Okay, on the next one we have f of x is equal to, again, the numerator, and I would like to rewrite f of x as a product of the quotient times the divisor x minus c plus the remainder. My f of x in this case is x cubed plus 4x squared minus 5x minus 9, and that is equal to my quotient, x squared minus 1x, times my divisor, x plus 5, plus my remainder, in this case is minus 9. On our last problem, we have f of x is equal to x to the 4th minus 16, and we're trying to rewrite that as a quotient times a divisor plus a remainder. My f of x is going to be x to the 4th minus 16 is equal to q of x, or my quotient. In this case, my quotient is x cubed minus 2x squared plus 4x minus 8 times my divisor, x plus 2, plus my remainder. Well, in this case, my remainder was 0, so because my remainder is 0, that gives us some added information, because not only do we have this rewritten as a quotient times a divisor plus a remainder, but because the plus or remainder was 0, this is truly the factorization of x to the 4th minus 16. Something that you may not have been able to factor quite this way, we're able to factor out a linear term. So this is actually some powerful information here. We're going to be using this in the next couple of sections.